Hello and welcome to tutorial 4. So in this one we move to 3D, so the same previous geometry, okay, the tutorial 3, but now we go to 3D. So as you go to in the team channel, but also as you go to the web page, you will find the links here. You have all the links for the videos and the material, okay? So you can download the ansys workbench project, the Fluent cases, or just the clean Fluent mesh with the settings and also geometry in UNIGE format, okay? So if you want to reproduce results here, you have everything. If you want to start from scratch, I recommend you to get here and set up everything. So let's move to this case. One different to the previous one, that now I will move outside of the I will move outside of the ansys workbench when running Fluent. So in this case, we have only geometry generation and mesh generation using ansys workbench. And now we go right ahead and run everything in Fluent standalone, okay? We know how to run Fluent within the workbench, but I prefer to do it outside. So now I go right ahead and get my cases set up here. Okay, so let me present you the case. So basically it's pretty much the same as the previous geometry. Okay, so see that here now we have the geometries 100 in the right dimension. The previous one we scale it in Fluent. Now I'm giving the right dimensions, and the difference here now is 3D. We have this pipe, okay, and see that's pretty much the same. You get the previous profile. What you need to do now is create this profile here and then do an extrusion. So I'm going to show you one way to do this. There are many different. So basically what I'm going to show you is just you create this line here, then you create this profile, this circular profile. Remember, this profile must be attached to this path, and then using this sweep utility you are going to sweep it and create this body. Then here also we're going to create this something similar, so you can use extrude or sweep. So you create a circle somewhere here, you have all your dimensions, and then do the extrusion, create the boolean, and voila, you are ready. So you are going to get the whole pipe. Then probably we can use some other tools to split this profile in two and use symmetry. We have all the conditions here, so it's the same as the previous case, as you see. Remember, I will enable again here the temperature equation, but if you want or if you prefer, you can enable the passive scalar. It's up to you, will be the same. Okay, so this is what we have. We have this mesh. Okay, so see that in 3D, since that become bigger meshes, you are going to have a larger cell count. Now you need to pay a lot of attention to mesh quality, but see, still is a nice mesh. Okay, we add our inflation layer, tetrahedral meshes. You can use any elements, up to you. Okay, and see here that we added some refinement in this small pipe. Okay, in the surface. Okay, like with in the 2D case, but in the 2D case we selected the edges there. We have this cut plane just to visualize there the mesh, and then we have the results. Okay, so we're looking here symmetry plane and those cut planes. So I will show you how to create the cut plane. So it's the same pretty much as in 2D. You create a line, now you create a plane. Okay, so you choose the location, and see here that also we have isosurfaces where the temperature is 25. So it's difficult to see here. Well, later when we do the post-processing. So the post-processing also is a little bit more time consuming as 3D. Now you can create these isosurfaces, click planes, but the idea is pretty much the same. Okay, then you can plot vectors. So see here that the behavior. Okay, so here we're in the cut plane, but probably if we move the cut plane in the symmetry plane, if you move the cut plane somewhere else, you are going to see recirculation zones. Okay, so see here the vectors, and also going to show you the string, how to release strings live from a patch. So here you are releasing strings that's from the inlet, also from this inlet, and these strings that basically following the flow. So sometimes this one can give you a better visualization than vectors. Okay, as in vectors, be careful when plotting this one, because if you got half a large mesh and you plot all the vectors, it likely will crash your computer because you have too much information, say for streamlines. Okay, so you usually don't put too much streamlines, otherwise it will crash. We're going to see that in works. And here we have temperature contours at the boundaries. Okay, so also you can plot that information. So see hot and cold strings there, and you have all the mixing. And again, you can put your monitors, mass flow, the weighted mesh outlet of here in the outlet is up to you. Okay, and you can do the same post-processing as previous, plotting the turbulence profile, everything. I'm not going to do it here, I leave it to you. Okay, we have done it a lot. Finally, well, so residuals okay, here. So see that we have a very nice smooth convergence. See that here we have the iterative average of temperature of the outlet. Okay, so this is the facet average. We're monitoring, for instance, here a force, okay, at the wall, so the X component. So see that they're becoming very stable. And here we have the mass flow imbalance. Okay, so see that is close to 0. So that's all that we're going to do for this case. So now let's move to ansys workbench. So feel free to download the cases here, and see you next video. Thank you for your attention. Bye.